Hi everyone, my name is Sam and welcome to my Next Gen AI Guy YouTube channel. In this tutorial, I will going to explain you how to fine-tune newly released Llama 3.2 11 billion vision language model on a custom dataset. So we are aware of that Meta has released Llama 3.2 vision model. Vision language model have two models. One is with 11 billion parameters and next one is 9 billion parameters. For this project we will going to utilize 11 billion parameter and we will going to fine tune that model. So let me show you the model. So this is the Llama 3.11 billion vision instruct model which is available on a Hugging Face. This is the model which we will going to use and we will going to fine tune. So before explaining to the code, let me show you that how to get access to use this model. First you need to have access to this model, so you need to click on this expand on and scroll down, and at the end here you need to fill contact information. After filling this information you just need to click over here and click on submit. Generally it will take 1 to 2 days. Sometimes you will get access of this model within a day, so you will get a mail when you will get access to use this model. After getting the access, what you have to do when you are creating an access token, so how to do that, you need to go to the setting and then you have to click on this access token, and over here just click on this create new token and give the name and click on this read and write, and don't forget to select that repository name. After getting access you will get your model over here. As you are able to see over there that I have access of this Llama 3.11 billion vision model, so I will click on this. Based on that I will going to create the token, and that token you need to paste in your Google Colab. So that was the way to get the access of this model and create a Hugging Face token. Next I will going to show you that what is the dataset which I am using, and this dataset has been provided by the fields, and this is the Amazon product description. So this is the dataset which I am going to utilize to train the vision language model. How to do that I will going to explain you in depthly that whole code, so you will get a better understanding of how to do that. So first I will going to tell you that key steps in fine tuning a virtual language model. So main thing, before fine tuning the model you have to define your use cases. First you should not directly start fine tuning the model. You have to define your use cases. Do I really need to fine tune that model, or that model is already capable enough to generate the outcome as I want? So what you can do that you should first test that model on your custom dataset, that how it is performing. If that is performing well, then you don't need to fine tune that model. If it is not, in that scenarios you can choose to fine tune that model. So let's jump to our code, how to fine tune that model. So this is the Colab notebook which you can find in the description below. This is the notebook. In that one I have written the whole code to fine tune the model. So you can click on the link and get that notebook and you can start fine tuning your Llama 3.2 model. So first we need to install these packages. These are the packages which are required to run this project. So we are installing the Torch. This is a deep learning framework needed to train the model. And next we are using a TensorBoard, a tool to visualize training metrics such as loss, accuracy, etc. And below is a Python library which we use for image processing, like loading an image for a model. And here we have a Torch Vision. This Torch Vision provides dataset, models and transform specifically for computer vision. Next we are installing a Accelerate, a Hugging Face utility to handle multi GPU training within ease. And next we are having Hugging Face to load the model and dataset. Here we are installing the transformer. With the help of transformer we can load and use large language model like Llama 3.2. Here we are installing the dataset. This package will allows us to load the dataset. Accelerate I have explained. Evaluate, we are going to evaluate. Next we are importing bits and bytes to optimize memory usage. And TRL, a library used for a fine tuning large language model. This is the PEFT, which is parameter efficient fine tuning, and from there we will going to import LoRa, which is low rank adaptation. And after that QuenVL utils, this package we are importing to help with the processing image and vision inputs for the model. So you just need to click on this run and it will going to install all the packages. After installing that, next we are importing a login from Hugging Face Hub. So the access token which you have created, that token you need to pass over here, and after that you just need to run this one. So that authentication to load the models will going to take care by this code. Here we have defined the prompt. So that prompt is create a short description based on the provided product name and category and image. Only return description. The description should be SEO, means search engine optimized and for a better mobile search experience. So that is the prompt we are going to give to the model. And so here we are highlighting the product name, and that product name we will going to take it from the dataset when we are going to load, and here the categories also. And after that we are importing the load dataset from the dataset, which will allows us to load the dataset from the Hugging Face. So this is the function we have defined, which will allows us to format the loaded dataset. Here we need to give the dataset, and what we are going to return, this is the dictionary. In that one the message is given, and then next is a list. Here we have given the two role. First one is a user, next one is a assistant. So the model is going to learn the interaction between this user and the assistant. In the user, what content we are providing over here is that text, image. This is the two things we are providing. In the text we are giving the product name and the category, and the image. So let me show you in the dataset for a better understanding. So this is the image we will going to feed. So these are the image, and here is the product name like star is toys, and categories, which categories it will going to fall. So here it has given the Barbie fashion doll, and the category is the toys, games, doll. That both will going to feed as a text, and this one will going to feed as a image. So user have given the text, both product name and category, and the image, and the assistant is going to have a description, which is over here, description. So this is the description of the dataset. So what will going to happen, that product name, category, and the image we will going to feed as a user, and the as a assistant, this is the description we will going to give as a assistant. Think it like you're training simple machine learning model like a logistic regression. So multiple input you are going to feed, and the one output is over there, that yes, true or false. So in here these three input we are feeding, and that output is given over here. Based on the interaction between the user and the assistant, model will going to learn. So if in case you given these three inputs, what should be the output it will going to generate. That is the motive of this, to fine tune that Llama 3.2 model. If you wanted to use or build some models, there are three ways. Either you have to train the model from the scratch, which is quite costly, and the next one is a fine tuning the model, not that much costly, but it is still costly. And the last one is a RAG based model, which is a retrieval augmented generation. Means during inferences time you are feeding information to the LLM model, that information which it has not learned during the training or fine tuning, that we called it as a RAG, means a retrieval augmented generation. So here we have given the dataset ID, which is this one. This is the same ID which is available in the Hugging Face. So that one you can copy and paste over there, or you can just use this Google Colab. Here we have given the split equal to train. So we are just taking the training part, as we are able to see over here that 1.35k rows are there. So that many dataset is present. So we are just taking this train part. So after loading, the all dataset will be in this variable. That dataset one by one we will going to iterate, and that sample we will going to feed to the format data. That format data functions going to bring that dataset into this format. So that whole dataset will going to be in this format. After that we are just printing this one. So as you are able to see that here we are having a role as a user, and the content as we are able to see over here, role as a user, then content. So here we have printed the message. So next we are importing a torch library, and after that we are importing the auto model for vision to sequence, auto processor, bits and byte config. So these three packages we are importing from the transformer. So this auto model for a vision to sequence model, this is specifically designed for a vision to text task, where input images are mapped to the text output. Next one is the auto processor, and this will prepare the input data for the model, handling tasks like a tokenization, image preprocessing. So those two tasks will be performed by this auto processor. And next one is a bits and byte. This is for a configuration, for optimizing the model using a 4-bit quantizations, that will be helpful for a saving memory while keeping accuracy. So here we have given our model ID, That model we have to load, and here we have given the bits and bytes int 4 config. So this bnb config configures the model to run in 4-bit precision, which reduce the memory and computational requirement. So 4-bit precision, so that we have given as a true. And next we have given the bnb 4-bit use double quant equal to true, means use a double quantization for a maintaining accuracy. And here we have given a bnb 4-bit quantite type is equal to nf4, and bnb 4-bit compute type is given as a torch.bfloat16. So we are using the bfloat16 data type for a efficient computation. So here we have loaded the model and tokenizer. How we are doing that? Here we have given the auto model for a vision to sequence from pretend. In that one we have given the model id, which is over here, and the device map is equal to auto. So this auto will allows us to automatically maps the model across available gpus. So after that we have given the torch d type is equal to bfloat16, and quantization is equal to bnb underscore config, which we have defined over here. And next we are just running that auto processor dot from pretend, and then we have given the model id. So after that you just need to click on this, so it will going to load that model locally. So you will be able to see over here. After running successfully, next we have to run this one. This is the function which we are importing from the processor. Here we have given our dataset which we have loaded and formatted that dataset, given the tokenize is equal to false and add generation prompt is equal to false. That data will going to bring into this format. This is the format which is required to train the model. So after running that, you will be able to see that your dataset have been generated into this format. And next here we are importing the LoRa config, which is from the PEFT, which is parameter efficient fine tuning. To reduce the memory usage while fine tuning, we will use QLoRa, quantized low rank adaptation, which quantize the model to 4-bit precision, allowing it to run on a smaller GPUs. Here we have given those parameters. This LoRa alpha controls the rank of the low rank matrices used in a LoRa. Higher value increase the capacity but may use more resources. And here we have given the LoRa dropout, means add some dropout during a training to prevent overfitting. So those two terms are there in the machine learning. You must have learned that overfitting and underfitting. To prevent the model from overfitting, we are using LoRa underscore dropout. So after that we are given the R equal to 8. R means rank of the low rank approximation. Lower ranks reduce memory usage, and bias is equal to none. So here we don't want to apply any bias correction, so that's why we have given as a none. For the target modules we have given this Q projection and V projections. Means Q means query projection and V means value projection. And so this focus on adaptation on specific layer of a model. So those two layers we are targeting. And here we have given the casual LM. LM means language modeling, where each word prediction is based on the previous seen data. After running this one, next we are importing SFT config from the TRL. These are the arguments we will going to feed. In this one we have given the output directory. So our output directory name is this fine-tuned vision llama model. So that directory will be created over here, and here we have given the number train epochs. This will specify that model will train for a 3 epochs. Increase in case you are using for a production or a better accuracy. For the demo purpose I'm just going to use a 3. Per device training batch size is equal to 4. So each GPU will handle a batch size of 4 sample during training. Gradient accumulation steps is equal to 8. Gradients will accumulate over 8 steps before back propagation. And here we have given the gradient checkpoint is equal to 3. So this will going to saves the memory by not keeping intermediate values of activations. And our optimizer is Adam W underscore torch underscore fuse. When you have learned neural networks, in that one we have a several optimizer. You must have heard about a Adam optimizer. So this is the advanced version of it, and this is the Adam W underscore torch underscore fuse optimizers. That optimizers we are using. And logging steps is 5, means after every 5 step or 10 step you will going to log. And save strategy is a epochs, means saves the model at the end of every epoch. So this is the learning rate based on the QLoRa paper bfloat16 data type to reduce the memory usage. And here we have given the max grade underscore norm is equal to 0.3 And this one we are using to prevent from exploding gradients. Here we are giving the warm-up ratio, and 3% of training step will be used for a learning rate warm-up. And after that, LR scheduler is equal to constant, uses a constant learning rate scheduler. And here we have given the push to hub. If you wanted to push to the hub, then you can true, otherwise you can write it over here false. Report to tensor board means logs the matrix to the tensor board. And gradient checkpoint keyword arguments we have given is equal to use reintrent is equal to false. Last one is a dataset keyword argument. Skip prepared dataset is equal to trip, means we don't want to prepare our dataset during the training. It's already prepared because we have loaded our dataset, we have converted into the format, and at the end we have applied the prompt template. So bring that whole dataset into required template. Then you just need to run this one, and after running this one we will move to the next cell. Here we are two things we are importing: quant to VL processor and process vision info. This one we are importing from transformer, and this one we are importing from a quen VL utils. So you know that quen is also vision language model, so that package provides several tools. So some tools we are importing from the quen to fine tune this model. So now we need to prepare the data set using a collate function and initiate our training process. The collate function is responsible for preparing a batch of data from the data set in the format that model can process during the training. It takes a list of example as an input and returns a batch of tokenized tag and processed image data along with the labels for a supervised training. So that's the motive of this collate function. So after that you just need to run this one. Next we will move to this cell, and here we have imported the SFT trainer, which will going to take the model, the all arguments which we have defined over here, those all arguments, then training data set and the data collator, which is function which we have given over here. And next we are given dataset text field, which is going to be a dummy, and here we have given the PEFT, which is parameter efficient fine tuning. That configuration which is written over here, and that configuration we are passing. And next one we are given the tokenizer, which we have loaded from the processor.tokenizer. So this is the processor, and from there we are importing the tokenizer. After that you just need to run this one to train this model. It's quite simple, trainer.train. So I was looking for a free GPU where I can run this project. After quite wondering, and I found out that Lightning AI is a quite good platform. Over there I can find out the free GPU. So I will try to run this project over there. As you can see that the training has been started. For this project I have tested different GPU. Let me show you which GPU which I am using. So I am using L40S with 48 GB of memory. So in that one it's running fine. In case of I tried A10G or L4, it didn't work on that one. So it working fine in a L40G and with 48 GB of memory. I tested on 28 and 20 GB memory, but it didn't work on that one. So I got out of memory error. If you wanted to run this model, if you wanted to fine tune Llama 3.2 vision model, that case make sure that you have a good enough memory. You can definitely utilize this Lightning AI. It's really good. The GPU which I am using and the memory I am consuming, it will only going to charge me around $2 for a per hour. So if you wanted to try it out, you can try. For that you just need to log in into the Lightning AI, and it will take 1 to 2 days to verify your account. After that only you will be able to use. So you just have to create your studio, and in that one you can create IPYNB file, or if you wanted to run in the module, then that also you can do. Let me show you that what are the GPUs does provide. So Lightning AI provides different GPU: T4, A10, L4, L40. So these are the description of this GPUs. If you wanted to try, you can go with the A100. I think that's a better one. So you will get a multiple GPU option also, but definitely you need to pay for it. As you can see, I have tested the L4 also and A10G also, but it didn't work in those GPU. And L40, it's only charging $2.17 per hour. So that's a good one. I think you can use it to fine tune. So I'm not going to fine tune this model. So I just wanted to show you that it's possible to fine tune this vision language model on your custom data. In case if you wanted to fine tune, you can do it in Lighting AI, or if you have a GPU, you can do it on that one. So that was the way to fine tune Llama 3.2 11 billion vision model. So I hope you guys like this video and you have learned something new today. I will request you to please like and share this tutorial with all of your members, and please subscribe for more such videos. Thank you for watching.